SPC tool, Pareto Diagram, Chapter 3. The Pareto Diagram is one of the 7 statistical process control tools, and this is a methodology for monitoring a process to identify special causes of variation and signal the need to take corrective actions when necessary. The main objective of the SPC methodology is to eliminate the root cause of the problem. Now there's 7 tools for the SPC series, and this is the first one, the Pareto Diagram. The Pareto Diagram is used to identify the most important problems or the most important defects of the most important good situation. The advantage of it is that it provides a visual impact of those vital few characteristics that need attention. It's also related to the 80-20 rule, that 80% of the problems are caused by 20% of the situation. Also, resources are redirected to take the necessary corrective actions with the main objective to eliminate the root cause of the problem. Now, it is a graph that ranks data classifications in descending order from left to right. Also helps a team focus on causes that have the greatest impact. Displays the relative importance of problems in a simple and visual format, so this is a visual tool, and helps prevent shifting the problem because it's focusing on the cause that has the greatest impact. You are just focusing on those specific areas so you can apply corrective actions to remove the root causes. This is how it looks like. So it's a graph, and it ranks the data in a descending order from left to right. Also shows the vital few, which is the cumulative percentage, and you can find that in this case 80% is caused by A, B, C, and D defects. So this is the way that you read the graphic. So how do we build one? Well, if you don't have the data, the first step is to collect the data. So to collect the data, you have to determine the method of classifying the data by problem, by cause, by type of nonconformity, etc. Okay, once you have the data or the method of classifying the data, you have to decide if dollar best or weighted frequency or frequency is to be used to rank the characteristic. Then you collect the data in the right time interval. Okay, this is when you don't have the data. Also, in this semester, we're going to learn that there are different types of data, and the type of data have different tools to use to be analyzed. And it's usually when we want to collect data, we need to think about the results. What do we want to achieve? Once you know what you want to achieve, you can work your way back until you determine the type of data that you're going to use. Step number 4 is summarize the data and rank order categories from largest to smallest, because that's the way that the graph is visually seen. Then you compute the cumulative percentage to be used, and then you construct the diagram and find the vital few. Okay. Now, if you have the data, say that you are given a just data set, what you have to do is you rank order categories from largest to smallest. You determine the frequency, you calculate percents, which is the frequency divided by the total frequencies, and then you calculate the cumulative frequencies, calculate the cumulative percents, and construct the diagram. And let's work an example. This is from Chapter 3, Problem 1. It says construct a Pareto diagram for replacement part for an electric stove. There's 6 months of data. You have oven door 193, timer 53, front burners 460, rear burners 290, burner control 135, drawers roller 46, other 84, and oven regulators 265. So we have the data. So our first step is to order the different categories from larger to smaller. So this is what we do. Step number 1, we classify the data in descending order. So you got that the front burners are the highest value. So that's the first one. Then you have drawers rollers is 46. And usually all older you can put it at the end. Usually the older is just a collection of other type of defects or events, and they are collected and you put it as a all together at the end. Okay. Then once you have that, and this is the defects, what you do is you sum all of those defects, and that give you a number. That number is going to be useful to calculate the percentage, the frequency percentage, which is divided the frequency by the total sum of the frequency. So it's 460 divided by 1526 give you the 0.30. Okay, and then 290 divided by 1526 give you the 0.19. 265 divided by 1526 give you the 0.17. Then you calculate the cumulative frequency, which is it's just adding the frequency. So the first one is 460. 460 plus 290 is 750. 750 plus 265 is 1015. 1015 plus 193 is 1208, and then until you get to the last one. And then you do the cumulative percent, which is, once again, you can sum all of this cumulative frequency, and then you divide 460 by the total, and that gives you the cumulative percent. So that's how you build the values. And the last step is to plot the data. Okay, when you plot the data, you can use Excel, you can use Minitab, which is statistical software, or you can do it by hand. So let's start with Excel. So what I did is just copy and paste the table with the different values, and you will go to data. This is Excel 2007. You will go to data and then go to data analysis. If you don't have the data analysis add in, you have to go to add more commands. Click more commands, and they will be part of the add-ins. These are the inactive ones that you have, and these are the active. So if that analysis tool pack is no part of the active one, it will be inactive, and you just have to add it in. Double click, and it will start the process. Okay. So I go to data analysis, and then from data analysis, I select the histogram because that's what Paretos are for. Then I select the input range as my number of defects. So I just highlight and do it. I check the label, and this label is to allow me to have in that input range other than numbers, which is the label, the frequency. Then after that, I check Pareto, cumulative percentage, and chart output, and click OK. This brought me to another worksheet within that Excel file, and it shows me the histogram. Now, one thing that I don't like it from the 2007 version is that it will put together all the different defects in 3 main categories. So combine the higher one and then the lowest one together, and then it shows you the vital few, which is the cumulative percentage. Now 2003 that's better. So if you have 2003, you can always call me or stop by during my office hours, and I will guide you through how to do a Pareto chart in 2003. I don't have 2003 in this computer. That's why I'm not able to show it. Okay. Now the other way to do it is through the Minitab. Okay. So Minitab is a statistical software, and what you do is just copy and paste the different the defects. Instead of having the names, I just name it A, B, C, D, E, and then you add the frequency, which is the frequency of that occurrence. Then you go to Stat and then Quality Tools and select the Pareto chart. Then in the defect or attribute data is the first column, which is the defects, and that will help you to name your or label your data. And then frequencies in, you select the number 2, which is the frequencies, which is the frequency of occurrence, okay? Then you click OK, and it will show the Pareto. So this is the Pareto chart. You see it's more complete than the one done in Excel 2007 because it shows the different defects and also shows the vital few, which is the cumulative percentage. The way that you read, the way you analyze is that you can explain that if you go to the right size, which is the cumulative percentage, you can see that 80%, and then where it touches the vital few, you go down, and you said that, well, 80% of the problems are caused by A, B, C, and D, which is the type of defects. Okay? Simple to use, simple to do. And this is how it looks like. This is a Minitab 15, and the one that I'm using right now is Minitab 16. Okay? So once again, the Pareto diagram is a visual tool, and it helps you to understand what are the different defects that are causing the major impact in your process. It can be done using Excel, statistical software such as Minitab, and you can also do it by hand. So this is all for Pareto diagram. This is the first SPC tool.